All right, I'd like to introduce today's panelists and give you a quick overview of what we'll talk about today. My name is Erin Caldwell. I'm the Vice President of Marketing here at Drishti, and we're very excited to have you at the webinar today, How New Tech Evolves Standardized Work. Continuous improvement is based on developing processes and benchmarks. And one key system of these benchmarks and processes is standardized work, which is what we're talking about today. That started with Frederick Taylor, and it has evolved throughout the last century. It's a means for minimizing variability and controlling quality and output. So what we're here to discuss today is the next evolution of standardized work, which is being driven by technology like AI. So a few things about our discussion that may stand out to you. Number one, the new technology we're highlighting is also based on the concept of standardized work, which we'll talk about a little bit more in a minute. And number two, that despite the introduction of technology, to be effective, standardized work still requires input from people on the line. So without any further ado, we're going to introduce today's panelists. We'll start with Dr. Prasad Akella, who is Drishti's founder and board chair. Hello, Prasad. Prasad is the team that created the world's first cobots at GM in the 90s. He is a voracious innovator with more than a dozen patents and both an ASME and an SME fellow. And last month, we're happy to announce that Prasad and Drishti's co-founders were given the Robotics and Automation Innovation and Entrepreneurship Award by the IFR and IEEE for their work at Drishti. So Prasad, we're very happy to have you today.
My pleasure.
And our other panelist today is Dr. Jeffrey Leiker. Hello, Jeff. Jeff is Professor Emeritus of Industrial and Operations Engineering at the University of Michigan. He is an unapologetic Wolverine and a professional speaker and advisor through his company, Leiker Lean Advisors. He's probably best known, though, for his deep study of and expertise in the Toyota production system. And he's written several books on the topic, including the book, The Toyota Way. And just a quick reminder, we will be giving away several signed copies of the book on today's webinar. Hello, Jeff.
I'd simply interject and tell you that I'm an unapologetic Wolverine as well.
Okay, my video is turned off and I can't turn it on. Somebody else had turned it. Okay, here.
There you are.
No, there I am.
Welcome, Jeff.
Thank you. Thanks for setting this up.
All right, so let's dive into the content today. We have a lot to cover and a little bit of time. So starting out, standardized work is obviously the foundation of lean manufacturing, but it predates lean by about 50 years. It was introduced, as I mentioned, by Frederick Taylor in the 1900s. So why is it still so foundational to manufacturing? And frankly, how has it stayed relevant for more than a century? Jeff, do you have any thoughts?
In the early days, say in around 1915, almost all work was done manually. There was some automation and there was equipment, but a lot of it was repetitive work, things like shoveling, iron. And a guy named Frederick Taylor, who's known as the father of industrial engineering, created what he called scientific management. And the root of it was standardized work. The question was, how do you get the workers to be more productive? And he could go into virtually any place and just observe the workers. He would find the one best way done by the fastest worker, and then he'd teach that to the rest of the workers, and productivity would be up by 50%, 100%, sometimes triple. And he just did that easily because there was no standard and people were just doing the job however they felt was right. The result of that was he created an army of these scientific managers who were actually industrial engineers. And he believed that they were the only ones that could figure out the best way to organize the work. And if the worker or supervisor tampered with it, they would mess it up. And so therefore their job was to just do what they were told and not think. Later at Toyota, they changed that rule. They still use standardized work, and some of the basic principles of industrial engineering were still the same, but they turned it on its head in the sense that they believed that the worker and the supervisor who were there every day should own the standardized work so that they can improve upon it continually, because they didn't believe, Frederick Taylor believes there's one best way, and then you set it up that way and just leave it alone. Whereas Toyota believe there isn't really a best way, there's a best known way right now. And then you need somebody to keep on examining it, finding opportunities to improve and continuously improving. So they taught essentially the supervisors and the workers to become industrial engineers. And that led to huge productivity gains for Toyota. And then when the Toyota production system became popular in the 1980s, then standardized work sort of came along as part of the package. The real goal is to produce repeatable, high quality work that's very efficient. And with robots, you can program it. With people, you can't program them. You have to teach them. And then again, as you find better ways, then you have to teach them all the better way so that they're all doing it in the best way at that time.
Actually, it's interesting what Jeff just said. It's like I was at a bank in India 20 years ago, and I was surprised to find all of the signs of Toyota production system in the bank there. Every file cabinet was marked, they had 5S to everything. And that sort of, I think, is the broader idea that I want to sort of complement Jeff's commentary with. I think the standardization has a role in every process. And my wife at home runs what we call a COVID protocol, and the COVID protocol evolves with every emerging, variant of COVID that shows up. And then some parts remain the same and some change. And I think that's the core thing that I take away from all of this, which is when you have a process, having a standardized way of attacking it and then improving the standard is a core element. And that's why there's been such longevity to this core concept for over 100 years. And from an execution perspective, I think there's two parts. One is the philosophy. You can have it doesn't matter what your philosophy is, as long as you stick with it, it's important. And the second is technology complements it. And I think that's part of the conversation we'll have today, is how technology complements this core commentary. And this thing, I think, is here to stay forever.
And Prasad, before we move on, we have a question from Bill, who asks, he's familiar with Industry and Quality 4.0, but can you just quickly explain the difference with Industry 5.0?
Sure. I'll take a pass. Henning Kagemann, the guy who wrote the Industry 4.0, and I were chatting not too long ago, and he commented, and my comment to him was, people are absent in all of the discussions on Industry 4.0. And I think what the market is trying to do today is recognize this gap, recognize that people are such a large part of these processes, because the problem solving, the interpreting of the data, the driving of the actions are all about people. That's thread number one. And thread number two is that the bulk of manufacturing is done by people, about 350 million people and 3 million robots. So I think what Industry 4.0 is trying to do is bring people in to the conversation. 5.0, sorry, is bringing people into the conversation, people who are missing in 4.0.
Jeff, anything to add there?
Well, just that another thing, of the many things that Toyota is good at that are part of Toyota production, the Toyota production system, is visual management. And the idea of visual management is I should be able to tell at a glance whether the standard is being followed or not being followed. And they often use simple red, yellow, green, like a traffic light. And if it's green, it's okay. If it's not, then there's a problem. And then somebody has to be trained to react to solve the problem. If you look at a lot of the computer displays we see around the world on our smartphone or our computer, they're actually pretty poorly designed. And one common mistake is to put too much information on the display, which we can understand if we've studied it and used it repeatedly and we have the time to look at it and pick out the information we need. But when you're actually doing work in real time, you don't have that kind of time or attention span. You have to be able to, at a glance, know the key factors and whether it's okay or not. So I think as you get to Industry 5.0, human computer interaction means really good visual management and really good display of the information. And that means also picking out the most important information for that person for that job.
And isn't it fair to say, Jeff, that the most important thing is there a deviation or not? It's as simple as that.
That's a good point. So that the red or yellow means it's sort of a problem, but there's still time to solve it. Red means stop. And what they're stopping for are deviations from the standard. So first you have to understand the standard, and that requires human ingenuity to figure out the best way we know today. And then when you know this is the way it should be, this is the standard for the product, this is the standard for the person, for the process, then you want to signal any deviation from that standard, which leads, in the best case, to problem solving by well-trained people.
And just real quickly, in 30 seconds before we move on, Alejandro asks, is the concept of Industry 5.0 in line with the concept of Society 5.0 from 2016 Japan? Are either of you familiar with Society 5.0?
I am not.
Neither am I, I'm
It's hard
afraid.
to keep up with
Yeah.
all these.
I'll have to get back to you offline, Alejandro. Thanks for the question. So moving on to the next kind of section here. So Henry Ford obviously was a big standardized work supporter, and he helped evolve that practice pretty significantly. But one of his major contributions, you can see by the quote, is he normalized the idea that standardized work doesn't stop. There isn't a plateau that you reach, and then suddenly the line is considered, optimized, and you can move on to the next problem. It's a state of continuous improvement, as you've mentioned, Prasad. So do you think that that is a concept that is widely understood across manufacturing, that it's a constant evolving process? Or do you think that people think there is still that perfect echelon that you can reach? And if so, how do you speak to people about shifting that mindset to using continuous improvement tools like standardized work?
You want me to take a crack at it? So actually, this reminds me, I think Henry Ford went on to say standardization doesn't mean anything unless you're standardizing upward in the context of doing better. This hunt for the elusive best, right? So coming back to your question, I think it's fair to say that the market, everybody in manufacturing knows about two core concepts: continuous improvement as being the anchor of competitiveness, and Kaizen being the tool that drives improvement, right? So I think the central idea of standardized work is pretty well understood. Every plant I go to, every plant manager I talk to, every line of service, everybody understands that. I think the gap really exists in the execution of it. And my mind goes back to an early customer of ours. They were making electronics on the plant floor. And then we found that our AI was having a little trouble figuring out what was going on. And when we studied what was going on, it was an interesting problem. So let's just say I hired you, Erin, you're my cousin, and I hired you to the company. It turns out it was my job to train you. And if you went and brought Jeff into the company, it was your job to train Jeff. And very quickly, it plays out like a telephone game, right? I mean, you start with one sentence and you end up with a completely butchered different sentence. So essentially, nobody's training to the common standard. And that was very clear to us that if you didn't get the training right up front and didn't get the training to the standard right, you will never achieve what you're aspiring to. And I think that is a common issue where the trappings are all in place, the documents are all in place, but the execution of that is not in place. And so I think when I think about the second part of your question, which is, what is this continuous evolution? I also run into questions that I get often, which is, I've used your system to balance a line. Can I just move all the cameras and move to another line? And there's almost built into that question is the assumption or the belief that you hit the goal and now it's time to move on, as opposed to you hit a goal and now it's, if it's important to the business, you then work to hitting the next goal. And you can't get to the next goal, or in fact, you give up much of the ground you picked up with the first goal if you don't continue to monitor what's going on. So that's, I think, part of what's going on in the market is this is the understanding gap, it's the execution gap, it's not a knowledge gap.
Yeah, I think that it makes a lot of sense, Prasad. And to your point, once you've achieved something, it's fun to say, hey, we made it, let's do something else. But there's also a lot of value in continuing to perfect and continue to grow that same achievement that you've made. So,
this achievement society that we have here, just riffing on that word, achievement. I remember when I first was introduced to all of this, 20 years ago, 25 years ago, I thought it was just a waste. Why do you want a creative guy like me and bound me in and say, this is a standard you're doing something? It just seemed too constraining. And what I've since learned is actually it is creativity enhancing, because all the grunt work of life is easily done. Because I like to pick up a shirt and a pant that always pair up, because I don't have to think about is that pair going to work? And then I can then think about what else I want to work on that day. So I think it actually is liberating, and I never understood that standardization can lead to creativity and liberation.
And Jeff, I'd love to ask you from Bill, when you have people input to improve, so for continuous improvement, a process, the trick is the documentation of the update to a new work standard. Do you have any suggestions as to how this can be done effectively and quickly and efficiently?
Well, obviously the easiest way is to do it by computer, and there's computer programs that will do that for you. I don't think what often happens in Toyota is the preferred way is to hand write on the document the change, because it might take a little time to update the computer, which might take overnight or a couple of days. I think the more important thing is who's responsible for doing that. And in Toyota, what is usually called the foreman or supervisor is called the group leader. The group leader has about 20 people, and then they have in that group of 20, they would have about 4 people who are workers, but they're known as team leaders, and they're very well trained on standardized work. So they're responsible for observing the deviation, looking at the standard, revising the standard, and then training the people. So it's self-contained. It's a closed loop feedback system within a small group instead of within a huge plant with many people. So I think that's what brings it to life, is the people at the front line being trained almost like they're industrial engineers, and both in standardized work and problem solving. And then in a sense, the paperwork becomes secondary.
Jeff, would you say that one of the things that Toyota does well is gets its line associates to behave like industrial engineers?
Well, like I said, say you have 20 people, 1 out of 5 or 6 will be trained to be a team leader. About half their time is offline responding to Andon to somebody pulled the cord because there's a problem. About half the time they're online working. And they have this special training to be like an industrial engineer. The other people who are not team leaders may not have a lot of interest, but they've been through training, but they may not have a lot of motivation. But when the team leader comes up to them and says, what was the problem? And they discuss it, they're happy to talk about it, as long as somebody else takes the leadership, which is why you have these leaders right on the floor at the front line.
So Aaron, I think what I was driving at to that question to Jeff was the execution of this is actually pushed all the way down. And by pushing the execution of standardized work and the processes down, you actually get broader deployment and engagement. And it's less about the digitization and more about the thinking and the mental engagement and the process. And the digital tools simply support that.
Right. So that they have specifically these roles. I've seen other companies who say, well, at Toyota, every worker develops their own standardized work, so we should do that. That's not what happens at Toyota, and it's not a good idea.
Yeah, and this is actually a really good segue into kind of the next topic, which is a lot of people are anticipating that full automation is imminent. Whether or not that's true, full automation would obsolete the idea of standardized work. So is there even a point to having standardized work anymore? And even if we think people are in the factory for the foreseeable future, why not just use computer programs and develop these instructions using the predetermined steps and time? So what is the argument that you guys see, and I'll start with you, Jeff, for creating a custom standardized work instruction for every single line and driving adherence?
Well, so one other thing I'd like to add about standardized, okay, I'll talk about the elements. So the 3 elements in Toyota of standardized work, one is the standardized work chart. And you can see there's a picture of the worker's motions in each cycle, which is repeating usually about every minute. And then there's steps to follow, and for each step, the time it takes to do the task, the time it takes for walking. And then you want it to add up to less than the speed of the line, or what Toyota calls the takt time, which in this case is 90 seconds. They also develop more detailed documents. So each of the high-level steps on standardized work that even might take as little as 3 or 4 or 5 seconds will have several different work element sheets that break it down. So you might say in attach mirror but the first step is to get the mirror. And then they'll get down to the detail of use your left thumb and forefinger to grasp the mirror. And these are key points. And that's what they use for training. So just saying, get the mirror doesn't tell me much as a worker. So I need more detail than that. So they develop that further detail that a lot of companies, even good lean plants, don't do. And then that's what they use for training. And then finally, the work balance chart or stack chart just shows for each job how it relates to the tact. And you can see if something's over the tact and a bottleneck. So these are 3 documents, but one of the key inputs into this, which you can't see it now, but it's on the standard worksheet, is the tact, and it's also on this stack chart. So 90 seconds. So given that you need to produce a part or build a car every 90 seconds, this is the best way we know right now to distribute the work and to perform the work. And we've eliminated as much waste as possible. What happens when the customer demand changes? Let's say 90 becomes 70. Now everybody's overloaded, so you have to reallocate the work. What happens if I add another part to this team? There's a redesign or a fix because of a quality issue, and now this team has to insert another part somewhere. Who does it? And that will change the standard work. So the point is that conditions are changing all the time, unless you always have the same demand and you never change your product. And you have to adapt to that. So who's going to do the adapting? In Toyota's case, they might have several thousand people doing work in the plant. And I don't want a few industrial engineers running all over the place trying to fix all the standardized work. So Toyota uses the work groups to do it themselves. And that's practical and almost necessary if you want to keep on updating the standardized work. The image of these predetermined times, which actually Toyota does use for a reach, there's a time, a grasp, there's a time. They use those for setting up the line initially, but it's very crude. These are sort of average times. And you're not thinking about how the actual work is organized, where the tools are. Can they move closer? Can I add a mirror so I don't have to look under the hood? So there's a lot of different, there's a real world to improve. And the predetermined times kind of pretends everything's the same, but it gives you a starting point. So there you're in the ballpark, and that's about as good as you can get. And then to get really good, to get really productive and efficient, you use what Toyota calls Kaizen, which is continuous improvement at the front line. So that's always going on, and it's necessary. It's not necessary if the job is automated, although interestingly enough, Toyota uses these similar methods for designing the work for the robot, because the robot doesn't figure out how to design its own work. So you still need standardized work. You still need a good workplace layout. They will still Kaizen the robots, and occasionally they'll Kaizen out of work robots so they have a free robot to move to someplace else. The difference is once you program the robot, it does what you program it to do over and over and over again. So for the person, it's extra effort to train them and to monitor them and to give corrective feedback to keep them following the standard.
Prasad, I'm curious, this lights out factory full automation, what are your thoughts on that?
Yeah, so the first comment I was going to make is Jeff is spot on. Even robot lines have SOPs or standardized work definitions. So the 2 thoughts across my mind in this context. The first is robots, while we like to believe will run forever, they don't. And there you have micro stops that lead to OEE reductions. And so one of the interesting things is, how do you know if a robot is doing something other than what it was programmed to? How do you know when it's introducing variability? And so the same notion of standardized work plays out absolutely the same way on the robot line. There's a second idea that crossed my mind as we talk about this, is that when companies are looking to start picking up the harder to do jobs, or the ergonomically terrible jobs, or jobs that need to be done absolutely consistently, there's a transition from the human to the robot. And maybe the cobot somewhere in the middle of that, but this standardized work definition is almost a template for them to pick up and think about. Yes, it's slightly different. The robot picks up something, it has to rotate, but the concepts are all the same. There's motion, there is action, and there is, completion of a sequence of tasks. Nothing different. That's the beauty of standardized work, is that it seamlessly flows across all parts of the plant.
So looking at standardized work misconceptions, we already talked about, this idea that you can set it and forget it. But what are other things that you've seen? And Prasad, I'll start with you, in your travels, that people either abuse or misunderstand standardized work and don't use it properly?
Yeah, I think the top two that cross my mind are the first is the coercive environment of this is the best way and you shall follow this way, as opposed to the flip side, what Jeff and others in the area call, what's it called? You call it I forget the exact term that you use for the collaborative way of creating standardized work.
I don't remember either, but
enabling bureaucracies. I think that's
sorry. Yeah, you're right. So there's
enabling bureaucracy is what you call it, right?
Enabling bureaucracy.
That's right. So I think that is the first thing. It's the how do you put this to work? So the notion of it is understood, but how do you put it to work? I think that is the first misconception. I think the second one is who creates it. And for me, this is a validation of, is the company really practicing lean, or are they speaking lean? The two are very different things. And if I find, and I talk to the people on the front line, that actually they have a say in what that standardized work looks like, then I know they're indeed lean, and as opposed to they're talking lean, right? So, and I think the last thing there is looking at when that document was last updated. So if the document was last updated, months or years ago, then it's not a living document. And this notion of it being a living document, of it being continuous, is another misconception. I'm sure Jeff has much deeper understanding of this. I'd love to hear your take on this.
I agree with everything you said, Prasad. I would add to that most places I visit, as far as they can get, is the standardized work chart itself. And I've even seen cases where it's under plastic so that nobody will mess it up. I saw one company where they hired an English teacher over the summer to write all the standardized work so it could be grammatically correct. And that was completely opposite of the idea of being a living document, first of all, but then second of all, there was no work element sheet. So there's no breakdown further. And so if you learn a better way to, there's a quality problem because your buckle is scratching the paint, and you learn a way to avoid that, there's no place to put that key point just on the standard worksheet. So they're not capturing those. The important point is really, how do you view this? And do you view it mechanistically as, I have standardized work because I have a document and I've thought about it and I've written it down? Or do you have standardized work, and I call that organically, which is in a living system where people actually are using it and following it? So more important than the document, whether it's grammatically correct, are the humans there following it. And actually what you want for standardized work is to become a habit, to the point where I don't have to think about it. I could focus on deviations. I could focus on thinking about better ways, so I could be creative. So the purpose of the standardized work is to have a baseline of a habit that works. And the way you get any habit is just through repetition. If I do it the right way enough times, it becomes natural and a habit. Then when it's changed, I have to learn a new habit, which is not easy. So I have to, again, through repetition and corrective feedback, I have to learn it to the point where now this is the new habit, this new standardized work. And then life becomes learning the standardized work till it's a habit, not just having somebody tell it to me in a half an hour, but actually developing the habit and then learning to redevelop habits over time, so that they can settle into the background and I don't have to focus on sort of the basics. Just like if I'm doing any sport, or if I'm in a fight in the martial arts, I don't have to think about what hand to use to punch back.
Jeff, do you get a lot of fights?
No, I don't. And I was never good at it as a kid. If I got in a fight, I was in trouble.
I noticed it. Go ahead.
Well, I wanted to, Susan asked a really interesting question I want to have an answer for the group for. So she says, does the standardized work model limit innovation from the line level workers?
Not at all, not at all. And I just pinged her and told her not at all. So here's the example I'd give her. The general assumption in the world is all line associates are equal. But we all know that not everybody is the same, and some people have talents in certain areas and others have in other areas. And part of the trick is to recognize who's creative, who's a problem solver, and who's actually trying to move the needle on what standardized work should be. And I would say that I'll give you the example of the gentleman we ran across on a plant floor. We were looking at cycle time information, and we recognized from the cycle time information that he always hit his number, and he hit it with a huge margin while everybody else was struggling. They were trying to take a rubber hose and insert it into a plastic nozzle. And in studying that, we realized that the guy was using, every morning he'd show up with a glass of soap water, right? And he would dip the rubber hose into the soap water and then slip it over the plastic nozzle and went in like that. Whereas everybody else is struggling. Rubber over plastic hoses, nozzles is not an easy problem. So I think there's a ton of creativity on the plant floor. I think standardized work actually gives you the ability to prove that your idea is working. And I think technology gives us the ability to measure different approaches. In fact, one of the things that the Denso team does, and I learned this, was to give the line associate the opportunity to run an experiment. So for your rotation, 2-hour rotation, do it the way you want it. Move the tools over, do what you have to. And if you come out ahead, then there's an opportunity for that to become the standard. And for me, that is a sign of creativity. You're changing what everybody else believed was the best and moving the needle on that. And go ahead, Jeff.
There's another important concept, which is the difference between individual learning and group learning or organizational learning. And if I come up with a better way and I keep it to myself, I might be better performing as an individual, but nobody else in the organization will benefit from it. Group learning means we have to all follow the new best way. And now as a group, we've learned this new way. So we need to share the best way. Now there's certain company environments where people don't want to share, because if they can do it faster, then they might be able to work a little faster and then take breaks. And if management catches them, it becomes a new standard and they change the standard for the plant. So but in an environment where there's some cooperation and trust, I just come up with a better way. I'm not sure anybody's even interested. But to the extent that there's others interested, the group leader looks at it, validates it, writes it down, everybody's taught my way, that makes me feel pretty good. I have some pride now. And I've had an impact on the group, not just on myself.
Yeah, definitely a cultural consideration there. Jeff, I want to get into the new tech side of this. So to your point earlier, Toyota really evolved and maybe even perfected the idea of standardized work using manual methods. They didn't have technology to do standardized work with. So what are new technologies bringing to the table that will again evolve how standardized work is created and tracked and measured in the factory?
Okay, so there's, like I mentioned, there's predetermined time standards, and there's programs that will create the standardized work and even take the basic elements on a standardized worksheet and create the stack chart and all that. So you don't have to do that. Toyota was never real crazy about that because they actually wanted the people to interact with the process. They talk about being at the Gemba where the action is and observing it carefully in detail. So they like the idea that people would write down the steps themselves, even with paper and pencil, so they could erase it. So the competition was between doing essentially what the worker does and documenting and calculating some things and the supervisor, et cetera, or by computer or by hand. What I was impressed by when I saw Drishti's technology at Denso, I'd first seen it when I was visiting Denso, was it's doing a lot more than just giving you average predetermined times. It's actually observing the job in real time and then parsing the video through artificial intelligence into steps, or if you give them steps, it's telling you how long each step takes. And it can tell you if you're missing a part, so it can detect quality issues. So there may be occasions where you want to do some sort of a workshop to train people on the standardized work and do it manually. But in real time, when people are working, they don't have time to stop every hour and take a stopwatch out and study the work. So I just saw the amount of information and insight available to the team as enabling, is very enabling to enable. And they also do audits. They might do a daily audit where the supervisor comes down and watches. And, but this is real-time audits going on all the time and signaling these deviations from the standard. And it's actual deviations. It doesn't depend upon a worker to notice themselves that they missed something. So the combination of thinking people at the workplace at the front line with this kind of real-time data, you seem to me to be extremely powerful and add value more than these kind of more primitive time and motion study computer programs.
So Prasad, I'm going to ask you if you don't mind to pull up a couple of videos and just show the audience what Jeff is referring to. But if you can, while you're doing that, just speak about this foundation of Drishti of standardized work and why you centered the technology from the beginning around this concept.
Yeah, so at one level, my observation was that the tools to enable these people that Jeff just referred to hadn't moved in 100 years. It was basically paper and pencil and a stopwatch. I mean, you may be using a cell phone now as your stopwatch, but it's conceptually still a stopwatch. And that was the thing that I found shocking and surprising. And the other part that, as I read about it, was it's almost like Frederick Taylor made it possible for America to become the powerhouse it was, because he taught us all, and then subsequently Japan learned from that, how scientific management can actually lift 300%, as Jeff said, improve processes, so you could do so much more with so much less. And so the core question, and this is what I'll show people right now in a second, is if you can automate all of this, bring new technology that enables, that provides the insights, provides the data, you still have the human being involved in the decision making, in the problem solving. And that's really what I was trying to build out here, was technology, humans and machines working together. So I'll take the next few minutes if it's okay with you, and I'll walk through a few of these and then we'll pick it back up.
Perfect.
So the first thing I want to start with is the notion of standardized work in AI. So I'm going to play this video here for everybody. And I want you to pay attention on the left-hand side to the operator doing, the line associate doing his job, and watch on the right-hand side what the AI does, and track this back to the notion of standardized work at the back of your mind. So essentially what's happening in this process here is the camera looking from above doesn't care who the operator is, male, female, left hand, right hand. It's looking to understand what steps have been executed on the plant floor. On the right-hand side, as the steps are executed, it's keeping track. So it's looking for three things. It's looking for completeness. Have all the steps that were required as part of standardized work executed? Were they executed in the right sequence? And were they executed in the right time window? So that is the core of what we do here. And now with all of with this possible, lots of fun things can be done. And I'm going to continue playing this here, and you watch the second part of what's going on here. And I sort of use the analogy of a spell checker. So you're going to see a standardized work spell checker running here. The person here executed a subset of the tasks in standardized work, and the system is able to identify right away which were or were not done. And this is exactly what Jeff was talking about, the ability to, in just a few seconds, do it even as the job is in the workstation. And it's this interaction between the operator and the job being done, the parts in the area, the assembly process, and the product being built is what we are focused on here. So this is the core of what we would start out with. Now, the application of this becomes far more interesting. So the first one I'll show you is using digital technologies to run the Gemba. So the Gemba coming to you. And I could be in Palo Alto, the plant could be in China, Mexico, wherever your plant is, and you could be in your headquarters sitting in Detroit. Now, so the first thing you're going to see is the ability for video to bring the plant to you. And the second is root cause analysis, problem solving that Jeff spoke about a little while earlier. So I'm going to run the tapes and then let's just watch what's going on. So first is you're seeing a line being sent back. And this notion of a line is central to the kind of problem solving we're talking about, the ability to line balances, the stack chart that Jeff showed a while ago. So this is where you got to get a call from your customer saying serial number 63, whatever is defective. And the question is, what happened? And so like YouTube, you can bring back video in seconds. And this unit was built on August 30th, 2021. So you can go back in time depending on your storage policy. And you can actually look at the station 3, in which you believe that issue might have been caused. Right? So literally you can see every step of the process. You can see if standardized work is being followed or not. And this becomes both a troubleshooting as well as a training opportunity for the company. So again, everything indexed to standardized work, so we can start figuring out what is done in a station and is it consistent with what we intended to be built. Now, with that, I want to go to the second example where this ability to watch the process starts translating into the stack chart and the line balancing and the takt time that Jeff talked about, going from 90 seconds down to 70, because the world is dynamic, demand changes, the product changes, everything changed. So with that here, let me just play this video. And what you're looking at here is units being built across the 8-hour shift, and down below is cycle time for every unit. So the first thing we're able to do is start telling you whether you'll make the number of units you need to make by the end of the day, you intend to make. And if you don't, we can start triggering business processes of extending, deciding to make and run overtime, or deciding that and letting people call home and let their families know that they're going to be late that day. And you can also start, as part of this, I think Jeff talked about the team leader. The team leader now, within 5 minutes, can actually start debugging problems on the line. So if you see that cycle ran over, we can bring up the video for you and show you which is the bottleneck station and play the video of the bottleneck station. And as the team leader, I know exactly what needs to be done here, and I can debug and say, with the parts absent, is this person new to the job? Is there a change in the process that popped up? So you're seeing video tied very closely to every data point in the system. Now here you're seeing that stack chart that Jeff showed. You can see here you got a 10.1% improvement opportunity. You can see that operators 2 and 4, even 3 are underburdened, and operator 1 is the one that's most burdened. And this is with thousands of data points, right? So this is the power of what we're talking about. And variability, I think Erin in her introduction talked about how variability is the kiss of death in these kinds of situations. You can actually look at the variation in a line, and this is the beauty. We're turning industrial engineers back to industrial engineers, to problem solvers, not to data creators. So the system produces the data and says, you need to look at these cycles. And the person looks at them and starts figuring out what happened in this. Why did it take 1,400 seconds when it should have taken 350? So this is where you can start balancing your lines. Actually, Kaizen events become half as long and twice as productive. Your NPIs become easier because you've got video to transfer across cultures and languages. It just changes how we hand over information, pass it back and forth. Now, third example here is this notion of errors and warnings. I think Jeff talked about the andon card, the 3 colors there. Mirroring that in technology here is the ability to look at an error that was caused on the line and to detect that automatically, so that you can now determine what your sort of mitigation of that is. And what you're seeing here is each step of the process being tracked in the system. And as so that way, is standardized work being followed or not? And if you look here on the left-hand side, you notice in step 4, instead of placing the thrust washer, he chose to scoop up balls and do something else. So this ability to look at what is expected and detected in near real time, if that's the use case we choose to, is important. And this drives training. Every customer I've talked to so far says, my labor force is very unstable. I have huge churn. I have daily absenteeism. It turns out that this is central. If I can see what I'm doing wrong, I will fix it. That's human nature. And we've seen that you can reduce training times in half, even as you reduce defect rates in half, because people absorb videos much better. Feedback like this can go back to your engineering team because you tell them, hey, we're seeing an issue here. In the past, they wouldn't believe you. Now with video, they know it's not Prasad causing the problem. Erin, Jeff, and Prasad on first, second, and third shifts are all having the same problem and having it across multiple days. So this is not just an individual problem, there's actually a systemic problem. Now here's another view that you can take from this data that changes how you run your business, right? This is a daily report with insights that shows up in your mailbox. I'm the plant manager showing up on the 11th of March. I know my day yesterday wasn't good. I know that station E110 was probably the issue across all three stations. I have videos to back it up. So my education cycle, my problem solving cycle, my problem debugging cycle are all much, much faster and more importantly, focused. So we're not changing the way you want to run your lean process, your Toyota production system. We're enhancing it, we're enabling it. And this is what digital does with it. I have one more if I have the time. Could I have a few minutes here or no?
You have 30 seconds.
30 seconds. Okay, 30 seconds. I love it. So what you're looking at here is something that drives your training process. So our system is able to identify warnings and errors, as you probably noticed from that first demo I gave. When you start putting these down and looking at them on a chart, you can start figuring out which shift rotation combination, which teams really need help and what type of help they need. So this is that process of feeding back to the line associates, to the team leader, and saying, as a team, here's what you need to think about with specificity, not train you on everything, train you on what needs to be trained on.
Awesome. Prasad, I'm going to take it back from you. We have a lot of questions coming in. Thank you so much for the demo. Before we get to that, though, I do want to ask Jeff, we've talked a lot about, obviously, why new tech and how new tech, but it's not just a matter of, okay, I want new tech. You know, implementation takes time and money and deliberation. And how do you recommend manufacturers actually practically do this? And how does standardized work factor into, you know, the ways that they deploy new tech?
Okay. So in general, when I look at the Internet of Things, I see that there's two parts, the Internet and things. And the things are the real world, what's actually happening in the real world. And there was a great quote many years ago, decades ago, from Bill Gates. And Bill Gates is a tech guy, so he was trying to sell tech. But he comes out and says that if you have a poor process, technology will make it worse. And if you have a good process, technology can enhance it and make it better. So I think often we're throwing technology at bad processes. We don't have good improvement processes. We don't actually know what the real problems are. We haven't solved the real problems. And I remember visiting a Toyota plant where they had this line that was completely done by robots that was feeding and picking and placing parts and going up and down through a bank of machines. And then there was the same product across the aisle being done by people. And I asked, when are you going to get to automate that line? And they said, when we're ready. This line that's automated had a very simple product, very, very low mix of variety. The other one has more variety and it's a lot more picky. And we're trying to get to the point where we've Kaizen the process enough that a robot can do it. So they were playing with the things first and getting it set up so that, and the robots aren't very good at thinking and adapting, even some of these smart robots. So you really need a very simple process first. And then if a person could do it very efficiently then and repeatedly, then you can say, now take out the person and put the robot in. I think, so when Toyota looked, for example, they've been looking at Drishti's technology. When they look at new technology, whatever it is, their question is, how does this add value, not to a poorly designed process, but to a good process? So they'll first revisit the process and make sure it's running really well and smoothly with the people. Then they will test out the technology and spend a lot of time training people how to repair it, how to maintain it, I mean, how to program it. And then they'll at some point turn it on when they think it's ready. And if they get it working in a pilot area, then they'll begin to move it to other areas, area by area, preparing the area. and trying to introduce it more quickly than the last time. So Kaizening the implementation process. And at some point, you'll see it everywhere, but that might take a while. It might take a couple of years instead of a few weeks or a month. So I do think that being systematic, being somewhat deliberate, and being patient to get the technology to work, to actually validate that it's adding value before you go live every place is very important.
Yeah, I also think there's an open-minded, you'd be open-minded. The technology will identify issues. The question is do you believe in process as being the primary goal and technology as being subservient to that? If you do, then you go back and you'll fix your process and technology will help you more.
And there's also an evolutionary process. I know from talking to Prasad that the first use of this technology is often to identify bottlenecks and send the experts in to fix the bottlenecks. And it's going to take some time to evolve to the point where work groups are actually using the technology in real time for improvement. I don't think this is a situation of assigning blame and criticizing people and saying, no, you're not doing it right. Using it in the way that fits your current level of maturity makes a lot of sense.
All right, I'd like to dive into some questions, see what we can get to before the session ends. So Alejandro asks, is Drishti technology based on video annotation, and how is the annotation done? Meaning, does the system learn automatically or does it have to be trained? And then so if there's a new operation, does it have to be remonitored or retrained?
Yeah, I'll pick that question up. Yes, there is a training component because that's how AI works. You got to teach the AI, the computer, what to look for. So, but the beauty is that we've minimized the effort required to train. So we've gone down now where we can do literally 10 videos annotated. We can take that, run the entire process. And it used to be 1,000 when we started. So it's a huge, huge shift in technology for us. And yes, you're indeed correct. If it hasn't seen the new process, if you make a change, it does need to be updated to know what's going on. But what we've done is we've designed our neural network so those updates are actually very easy and straightforward. If most generally, it's not like you're going to do something radically different. You're going to tweak something you already have. And it's typically well within the capability of the neural network to look at it. It's just a quick retraining process. And we help you do that pretty quickly, in a matter of days, actually.
We have a question from Chris. How flexible is this technology if the product being built varies between cycles? And I'm going to throw in a similar question that we also got from, sorry, I don't remember who the asker was, but how does this product work? It was Bandar. How do we run the system with high mix, low volume? So yeah. Two similar questions.
Yeah, so totally. I think this, so the first thing is we integrated the MES system. So we know what unit is being built, or if the different products being built on the line are sufficiently different, visually you can tell what's different. Now, once you know what unit is being built, it's programmatic to say, okay, I'm building product A, and product A is standardized work, looks like A1, A2, A3, A4, as opposed to B, and I'm B1, B2, B3, B4. And so the trick is in that synchronization and identification of what unit is being built, what type of product. And after that, the data is collected for product A is different than product B. It's all in a simple analysis, drop down in our menu. Say, show me the data for product A, as opposed to product B. So the trick is in the front end integration, which we actually do relatively easily.
Real quick, Prasad, there's a question from Alejandro. Is this system based on edge or cloud? And you can probably speak to that fairly quickly.
Yeah, so today the system is based in the cloud. But we're actually extending all of our technologies to move to the edge, depending on the situation. So I think at the end of the day, all the vendors in the space will get to some hybrid situation. One of the important things I want to distinguish between what we do and everybody else does, and very important, is we take a systems view. We look at all the stations aligned. So to create that stack chart that Jeff showed at the very beginning, to balance your line, you need to know cycle times for every station on the line. And most everybody else does not do that. Now, what this means is there's significant compute going on. And so we could do it in the edge, we can do it in customers, data centers, or we could do it in the cloud. And that's the evolution of the technology that's occurring on our side right now, moving exclusively from the cloud to other sort of topologies.
Jeff, I have a question here from Shmuel, who says, are there processes where manual is better than digital?
Sorry, ask the question again.
First of all, for for any complex process, how do you define complex? But if it's intricate, if the product itself is not totally standard, if some variation of the product, so I have to turn something a little bit to fit it in place. So anything that involves sensing and then adjusting, the computer is not always so great at. The other issue for Toyota is that at one point, and this goes back about 20 years, Toyota had gone much farther with automation in assembly than they ever had before. They're making a Lexus. They put in a lot more robots. The quality was actually very equally high. It wasn't better, but it was equally high. So it actually worked. But then the demand for that particular product went down, and they had all these robots depreciating. And the conclusion they drew is that with people, they could have moved them around and found good uses for the people. So to get the flexibility of flexing up and down to meet demand, they found that there was an advantage to having people. So they will have some mix of people and technology just for that reason, just to be flexible. And then when you have people that are doing something, say in a robotic cell that's welding, then they're also there to observe and to continuously improve. So you'll see people sort of strategically placed even in automated areas in a Toyota plant for those reasons.
And complementing what Jeff just said, there are many jobs that automation is not ready to do, right? And those are just not candidates, and we've got to be upfront. I mean, Elon Musk learned that the hard way. He tried to go even further than Toyota in that process.
Elon has learned a lot of hard lessons lately, Prasad.
Yeah. Lots, but independent of what he's messing around with, the fact still remains that based on this question, it's hard to do certain processes, and when it's hard, you better be upfront about it and ensure it's people who do it, because we're a lot more flexible, we're a lot more creative, we're a lot more adept at what we do.
And that's also the opportunity to improve the process to the point where a robot can do it.
In fact, that's one of the interesting conversations we're having with the robot manufacturer. They want us to provide data to them so they know where to put robots in for their clients, right? That's what they want to do. And it's just a fascinating problem, because this is what standardized work is. It's the same. It's conceptually the same. So and it's a national bleed over.
More stability, less variation, better candidate. Right?
There you go.
So one more question. We're a minute over time, but I'm going to squeeze this one in. This is from Shohei. Who manages the crowd data infrastructure? Is it the user, or does Drishti manage it?
Yeah, so we're a SaaS product, software as a service. So we manage everything. So the analogy you give people is, think of your MRI machine. The lab technician uses it and the radiologist uses it. They don't know what's inside. That's the same mental model. We want your line associates and team leaders to work with us to define standardized work. And then once the system is running, all you do is you consume it, you identify problems, and you problem solve using the data. We enable you, and we take all the burden of AI off of your back.
All right, folks, that's a wrap for today. Thank you so much, Jeff. Really appreciate you being here. Thank you for your time.
Thank you.
Thank you so much for your time as well. We look forward to another great conversation with you guys in the near future.
Yep, and anybody has any questions, they should just drop your mail or one of us, and we're happy to pick it.